Voyager 1, the farthest human-made object in space, is in trouble. The spacecraft, which has been traveling for nearly half a century, is experiencing serious issues transmitting data back to Earth. It has suddenly started sending a strange pattern of ones and zeros, which makes no sense. This has put engineers and scientists on their toes to diagnose and fix the problem from 24 billion kilometers away, so that the historic mission can continue to provide invaluable insights from its journey through space. But what exactly is causing the spacecraft to transmit this mishmash of data? Is this just a small technical glitch or a significant malfunction happening in the background? Finally, and most importantly, considering the spacecraft's age and distance, is it even possible to address this issue? To answer all these questions, it's important to understand why the probe is transmitting a strange pattern of binary digits. The Voyager spacecraft, just like computers on Earth, uses the binary system to communicate with us. It employs only two numbers, 0 and 1, to represent all kinds of information. Each 0 or 1 is referred to as a bit, and a combination of these bits can represent anything from numbers and letters to more complex data like pictures or sounds. There are three main computers on board Voyager 1, and the problem is linked to two of them. The first computer is called the Flight Data System, or the FDS. It is responsible for collecting two types of information from the spacecraft: data from scientific instruments designed to study the universe, and data related to the spacecraft's own health, indicating if all parts are working correctly or not. After collecting this information in binary format, the FDS processes and combines it into a single data package. This package is then sent to the second computer, the Computer Command System, containing the Telemetry Modulation Unit, or the TMU. The TMU's job is to transmit this package back to Earth. To do so, the binary data is first modulated onto a carrier signal for transmission to Earth. Once this is done, the TMU transmits the waves carrying the data received on Earth via the Deep Space Network. The DSN is a collection of large radio antennas strategically placed around the Earth, such as in California, Spain, and Australia, to ensure continuous communication with different spacecraft as the planet rotates. Once the binary data are received, it's further processed in data centers. Finally, the binary data are converted into human-readable formats like numerical values, graphs, or images that are further used for analysis and research. For over 4 decades, Voyager 1 has been sharing information in this manner, but recently, the spacecraft's communication system has witnessed a mysterious problem. Instead of sending the usual mix of scientific information and spacecraft health data, the TMU has been reported to emit a strange and repetitive sequence of ones and zeros that doesn't seem to make any sense. NASA hasn't released the exact pattern that the Voyager probe is sending. As a preliminary report on the issue, NASA has concluded that the primary problem lies with the FDS. For some unknown reason, the FDS isn't handling the information correctly. Since a piece of incorrect information is reaching the TMU from FDS, it is causing the TMU to transmit irrational binary messages back to Earth. Usually, when such a problem arises, the first solution is to restart the FDS by turning it off and back on again. This approach often fixes most technological problems here on Earth, and even in space. For example, back in 2010, when Voyager 2's data showed a similar issue due to a flip in one of the bits, the team performed a resetting command for the memory of the FDS, which successfully resolved the issue. This on-off mechanism even solved a glitch faced by the Hubble Space Telescope a couple of years ago. Following the same strategy, a reset was also performed on the FDS this time, but that didn't help. The problem persisted when the system was turned back on. This has prompted engineers and scientists to come up with more robust solutions, but doing so is more challenging than it seems to be. First of all, the spacecraft was built almost half a century ago by people who have long since retired. So, the The present team needs to go very deep into the old documents to see how the probe and its computers work. The technology is highly outdated, although several software updates have been carried out in recent decades. As a comparison today, even the cell phone in your hand can handle more than 100 billion instructions a second, but the Voyager's computers can only process 8,000 a second. Secondly, at the current distance of Voyager 1, it takes almost 22.5 hours for light to travel one way to Earth. So, whenever the team comes up with a possible solution and tries something, it's a 45-hour round-trip wait for the signal to get there and a response to return. But on the positive side, this isn't the first time Voyager 1 has sent back random data. Even in 2022, the probe returned some of its data through a broken computer on board, corrupting the outgoing messages. However, the engineers at NASA figured out the problem and fixed it. The Voyager mission was never meant to last this long. This incredible mission, originally designed to explore the outer planets, has far exceeded its initial goals and provides invaluable insights about the universe beyond our solar system. The probe is powered by a radioisotope thermoelectric generator, which slowly loses power over time. As this happens, the team behind Voyager 1 has to make tough choices about which parts of the probe to keep running. The last picture taken by Voyager 1's cameras was part of the family portrait series of images of the solar system, which were captured on February 14, 1990. This series included the famous pale blue dot image of Earth. This particularly significant photo shows Earth from 3.7 billion miles, or 6 billion kilometers away, appearing as a tiny point of light in the vastness of space. After these images were taken, the cameras and other non-essential instruments were turned off to conserve power. The focus of NASA engineers is to keep the instruments that send data back to Earth working for as long as possible. As of January 2024, only 4 out of 10 Voyager 1 instruments are on. The data sent by Voyager 1 are critical because the probe is now in a part of space where the sun's influence is feeble. And it's telling us about things like cosmic rays and magnetic fields in a place we've never been able to study directly before. However, as Voyager 1 travels further away, staying in touch gets more challenging. Signals take longer to travel, and they're much weaker by the time they reach us. Despite these challenges, Voyager 1's journey continues. It's not headed towards any particular star or planet, but in about 40,000 years, it will pass relatively close to a star named Gliese 445. In human terms, this is a long time, but it's a blink of an eye on the cosmic scale. One of the most special things about Voyager 1 is the golden record it carries. This record is like a time capsule, filled with sounds and images from Earth, intended to show other life forms, should they ever find it, what life is like on our planet. This record also has instructions on how to play it, and a map showing where it came from. The idea was to share a bit of our world with whoever might find it, even if that happens millions of years from now. It's like a bottle thrown in the cosmic ocean, carrying a message of who we are from a little blue planet far away. So Voyager 1's journey is not just a scientific mission, it's a story of human curiosity and ambition. Looking at what the twins have achieved so far, there is still hope for the recent technical glitch to be fixed. And if this key issue is resolved, scientists are hopeful that the spacecraft will continue until the mission's 50th birthday. Share this video with your friends and follow The Secrets of the Universe for more.